Yeah.
Alright, tell me when you're going. Say 3, 2, 1, go.
3, 2, 1, go.
This is thinking outside the box and finding the max volume with
Mia Ibarra
and Maria Cortez.
Okay, so I'm going to give you a description and a purpose for this project. So what we did is we had a 2D piece of paper. We transformed it into our rectangular prism, the box. And we only had the length and the width of the 2D paper, and we were able to find the maximum volume possible for our rectangular prism.
Here's the steps. So step number 1 is determine your length, width, and height as x, y, and z, with your length being y, width being z, and height being x. Step number 2 is find the equation of the length, height, and volume. And once you do that, now you have a system of equations. Step number 3, isolate the z and y variables from the equations that you have. And step number 4 is by using substitution, you can plug in the equations you found for z and y, or width and length, into the volume equation. Once you do that, here comes step number 5. Step number 5 says with that formula, plug it into your calculator and find the maximum, which is your x or the height. So when you plug it into your calculator, you actually get a kind of, figure you could say, which is a cubic function. And then you find the maximum of that, and once you find that, you get, it gives you an x value. And when you get that x value, that's going to be the x that you plug into, which is step number 6. Once you have the x, plug them into the equations of y and z to find their value. And step number 7, draw the box.
Okay, and as Maria was saying, for step number 5, this is our equation that we plugged into the calculator. So this is a visual representation of what it looks like in the calculator. And this top point right here was our maximum for our function, also known as our x value.
Which actually ended up being 2, 3.
And down here we just have the 2D representation of this box. So this is the same thing as this, just 2D. And on here we have the length, the width, and the height for the rectangular prism.
With the length being the y that we found whenever we plugged it in, which was 9.5, and then the height being x, because whenever it's folded over, the height becomes kind of straightforward, and it becomes this height right here, which we found was already 3. And then the width, which is z, equals to 9.
And that was thinking outside the box and finding the maximum volume with Mia Ibarra
and Maria Cortez. Catch you later.
Oh Lord, no.